Hi class, welcome to section 6.3. This section is all about formulas. We're going to work on evaluating formulas, learning some basic formulas that are used in everyday life, and we'll learn how to rearrange a formula so that we can get a different variable isolated. So a formula in general is just an equation that typically has a real life application. So you'll run into things like distance equals rate times time or I equals PRT, but all of those letters have meaning and represent something in the context of the problem. When you go to evaluate a formula, I often call it plug and chug. You're going to plug the numbers in for the given variables, and then you're going to perform the math operations with the proper order of operations to simplify it down to a number. The most basic formula that you'll run into in this section is the simple interest formula. The simple interest formula, in order to calculate your interest, you take the principal, which is the amount of the loan, the rate of the loan as a decimal, and the amount of time in years that you plan on having the loan, and that'll tell you how much interest that you're going to pay for it. So often we'll just represent that with I equals PRT. So for an example, let's say we have Chris Campbell. He borrowed $5,000 at a simple interest rate of 6.5% for 3 years. A, how much will Chris Campbell pay in interest at the end of the 3 years? Okay, so in order to do this problem, we first need to calculate his interest. So we need to use the formula I equals PRT. So in this problem, the principal is the amount that he borrowed. And in this problem, he borrowed $5,000. The rate is the interest rate. Now be careful because they gave you the interest rate at 6.5%. That's not okay. You cannot use 6.5. You have to convert that to a decimal and use 0.065. And then T is the number of years he's going to leave or have the loan. He's going to have the loan for 3 years. Okay, so let's just use our calculator and type that in. You can type it in just the way it looks with the parentheses and let the calculator do the arithmetic for you. You should come out to $975 in interest. For part B, they said, what is the total amount he will repay the bank at the end of 3 years? Okay, well, at the end of 3 years, he is going to need to pay the $5,000 that he originally borrowed, plus the $975 in interest. So he'll need to write them a check for $5,975. Another formula that's really common and not too difficult to use would be formula for volume of a rectangular box. In order to find the volume of a rectangular box, you need to take the length of the box times the width of the box times the height of the box. Okay, so in symbolic form, that would look like volume equals L times W times H. So for example, let's use that formula to find the width of a rectangular box of ice cream. Okay, so I'm going to shrink this up a little bit and give us some more space. We know that our formula is volume equals length times width times height. In this problem, they told us that the length of the box was 7 inches. They told us that the height of the box was 3.5 inches. And that the volume of the box was 122.5 cubic inches. You can just leave the label off. Don't let that label confuse you. You can just leave it off. So the only variable they did not tell us was the width, and that's what they want us to solve for. Okay, so the first thing I would do, I would simplify my right-hand side because you can multiply 7 and 3.5. So if you multiply 7 and 3.5, you're going to get 24.5 times your W. And now you can use what we did in the last section of homework where we have W being multiplied by 24.5. So to undo that, you would divide by 24.5 to both sides. Get your calculator to do the division for you, 122.5 divided by 24.5, and you'll find that the width of the box is 5 inches. Be careful on your label. Lengths should be plain inches, volumes should be cubic inches. Sometimes we'll represent real world situations, such as simple interest. And when we create an equation to represent this, that equation is called a mathematical model. A lot of people will just simply call it a model. A model is any formula, any equation, or it can have multiple equations in it. So get familiar with some different letters. Often you'll see Greek letters used in mathematics. A common one you'll see is the Greek letter mu. You can see lowercase sigma and uppercase sigma, lowercase delta and capital delta. This is lowercase epsilon, pi, theta, and lambda. Those are really popular, especially in your statistics courses. So if you go on to statistics after this, you'll see those often. We will have a statistics unit in this class, and one of the common formulas that you're going to see is a formula to calculate a z-score. So the formula is this: the z is equal to x bar minus mu, all divided by sigma, divided by the square root of n. So you'll have to be really careful when you go to simplify this in your calculator, and you'll have to make sure that you do the correct order of operations. Okay, so for example, I would like you to find the z value when x bar is equal to 120, mu is equal to 100, sigma is equal to 16, and n is equal to 4. Okay, so we're going to just substitute those numbers into the equation. Okay, so our equation is z equals x bar minus mu all over sigma divided by the square root of n. Okay, so first thing I would do is I would substitute the letters into their appropriate position. Okay, so they told us that x bar is equal to 120. So I'm going to take out the x bar, and I am going to call that 120. They told us that mu was equal to 100, so I'm going to take out mu, and I'm going to call that 100. They told us that sigma is equal to 16, so I am going to take out sigma and call it 16. And they told us that n is equal to 4, so I am going to take out n and place in a 4. Okay, now when you go to simplify this, there is a specific order. You need to first simplify your groups. Now remember that your numerator is considered a group. So we'll first take 120 and divide that by 100, which will give us the 20. I would also simplify your square root of 4. Your square root of 4 is going to simplify to be 2. You still have a group because you have an operation happening in the denominator. So you then need to simplify your 16 divided by 2. 16 divided by 2 is 8. And then last you can do your division. 20 divided by 8 is 2.5. So your z-score in this problem is 2.5. Some of the formulas that we use are going to use what's called a subscript. So a subscript will have a little number or letter next to your variable. They have no mathematical meaning other than it's a label. Okay, so when you run into a variable, let's just say variable A, and you see a little subscript 0 on it, often that will get read A sub 0. I have heard some teachers also read it A naught, only for zeros. If you see a little subscript 1, A sub 1, A sub 2. It's just to keep you organized, but like I said, the 0, the 1, the 2, they aren't actually included in the calculation. They're just an organizational tool. Sometimes, instead of evaluating an equation, you'll often be asked to rearrange the equation. So you'll be given a specific equation or formula, and one of the variables will be isolated, and they would typically like you to rearrange it so that a different variable is isolated. So it's just like solving an equation with numbers and letters. You're trying to get that letter on a side by itself. So for example, let's say I have the equation or the formula 2x plus 5y minus 10 equals 0. And I want you to solve for y. Okay, well, your goal is to get y on a side all by itself. Okay, well, first of all, that 2x is going to have to move. And since the 2x is a positive 2x, we're going to move it with subtraction. What you do to one side, you have to do to the other side. In addition to the 2x, this minus 10's got to get out of there. So the opposite of a minus 10 is a plus 10. What you do to the left, you have to do to the right. Okay, so you now have 5y on a side by itself, and then on the right-hand side, you have minus 2x plus 10. You cannot combine those because they are not like terms, because 10 does not have an x with it, so you can't combine them. You're kind of stuck, just like that. Now, y is still not alone because y is being multiplied by 5. So you will need to divide by 5. Y equals negative 2x plus 10 all over 5. Now, this is a perfectly acceptable answer. There's nothing wrong with this answer. You have officially solved for y. I will say, though, that sometimes they do want you to go a little bit further than that. So let me show you what I'm talking about. So you have y equals negative 2x plus 10 all over 5. Often what they'll have you do is they'll have you split it into two separate fractions. So you'll have your negative 2x over 5 and your 10 over 5. And the reason they'll have you do that is because the 10 and the 5 will reduce. 10 divided by 5 is a really nice number. 10 divided by 5 is 2. So often they'll have you split it. And then typically, they don't like the variable to be in the numerator, so you might see the 2/5 separated from that x like that. So when you're working through your homework, if they tell you you're not in the proper form, they probably want you to take the problem a little bit lower. So just be prepared for that. Okay, last example. An important formula used in statistics is z equals x minus mu divided by sigma. I would like you to solve this equation for x. Okay, we can do that. Let's get some room. So I'm going to first jot my equation down again. Z equals x minus mu over sigma. Okay, so the first thing we want to do to try to get x alone is you want to get rid of that fraction. So when you look at that fraction, that technically says that you are dividing by sigma. Okay, well the opposite of dividing by sigma is to multiply by sigma. Okay, so we're going to go to our equation and we're going to take both sides of our equation and multiply both sides by sigma. Okay, and what that's going to do is the divide by sigma and the multiply by sigma are going to reduce each other away, which is going to leave you just an x minus mu on the right-hand side. On the left-hand side, you have sigma times z, or z times sigma. That's all you can do with it, z times sigma. X is still not alone because x is being deducted by mu. So we need to do the opposite. The opposite of minus mu is plus mu. X is equal to z times sigma plus mu. And you've isolated your x. That's all you can really do with it. Okay, let me know if you have questions from the homework.